Welcome to homework.
So we have an acid called HQ with a pKa 4.89. So for part A, we have to calculate the hydronium concentration, where we have 3.5 times 10 minus 2 molar HQ. And then for part B, we have to calculate the hydroxide concentration, where we have 0.65 molar of HQ. Okay, so again, first of all, we're going to write our acid dissociation reaction. All right, so the next step, we're going to set up an ice table. Okay, and then we are going to put our initial concentration to our ice table. We don't care about water, so we have 0, 0. So we have minus x plus x. After dissociation, so we have 3.5 times 10 to the negative 2 minus x. And then we have x and x. Okay, so the Ka expression will be equals to our x squared. We multiply the concentration of both reactant over the potted concentration. Okay, so I'm going to make the denominator much more easier to read because the scientific notation is pretty long. So I'm going to convert 10 to minus 2 scientific notation to with decimal place. So essentially, it will be equals to 0.035 minus x. So it's just a way for me to say some space. Okay, so we want to find the concentration of hydronium. And then we are given the pKa. So if I take the one on the side on the right over here, our Ka essentially equals to the base 10 to the power of negative pKa. So the pKa will be equals to minus 4.89. So it will be 10 to the minus 4.89. Okay, so we are going to solve for this quadratic equation. So we are going to go to same page. So we are x squared. We have 0.035 minus x, and then we have our Ka. So to double check, I have everything right. 0.035 minus x, yeah, that's right. So we are going to solve for this quadratic equation. So we have 0.035 multiplied by 10 minus 4.89. And then we have minus 8, 10 to the power 4.89 to x, and I have x squared. So if I rearrange that, I have 0, x squared, and then plus 10 to the minus 4.89 k minus 0.035 times our Ka. Okay, so we are going to solve for the quadratic equation. Okay, so we should be able to find that x can be equals to 6.65 times 10 to the 4, or minus 6.78 times 10 to the 4. But again, we cannot have a negative concentration because it doesn't make any chemical sense. So therefore, this will be the x. And again, when we go back over here, x is essentially equals to the concentration of hydronium. So that's why this will be our answers. Okay, so move on to part B. When we have 0.65 HQ, what will be the concentration of hydroxide? So for this question, it will be it won't be that direct. But first of all, let's proceed with the calculation as usual, just like part A. Instead of using 3.5 and 10 to the left 2, we're going to change this to we're going to change this to 0.65, and then we will have 0.65 minus x, and the ice table is essentially the same, but we just start from 0.65. Okay, so when we go back to our equilibrium expression, so we have Ka x squared 0.65 minus x equals to 10 to negative minus to the power minus 4.89. So at the end of the day, we should have a quadratic equation like that, but instead of 0.035, we have 0.65. So I'm going to copy and paste this quadratic equation if you want to solve for it. So we have x squared plus 10 to the power of negative 4.89 x. We should have minus 0.65 times our Ka. Okay, so it's just the same mathematics, but we have different quadratic equation. So when we solve for this quadratic equation, we can find our x. So when we solve for that, we should be able to find out x equals to 2.89 times 10 to the negative 3 molar, or minus 2.9 times 10 negative 3. So again, we reject the relative answers. We're going to take these answers. So for this answer x, essentially is the concentration of hydronium when we have 0.65 molar HQ to start with. Okay, so therefore, this will be the concentration of hydronium ion when we have 0.65 molar of HQ. Okay, so and then but we want to find the concentration of hydroxide. If you remember again, the concentration of hydroxide times the concentration of hydronium will be equals to our Kw. Because we use water, it must be equals to Kw. So the concentration of hydroxide will be equals to our Kw divided by the concentration of hydronium, will be equals to 10 to the negative 14 divided by our 2.89 times 10 to the negative 3 molar. So again, we're going to solve for that. And we should be able to find that the concentration of hydroxide is 3.46 times 10 to the negative 12 molar. And this will be the answer for part B.